Yeah, recording in progress. Yeah, so like I mentioned, this is where we started the last time. We went through variables. If you can still remember, if you have any, at any point, right, you are welcome to stop me if something isn't clicking, right? So, and we talked about variable. It's just your way of pointing to data. That's what variables are. And then we mentioned that there are different kinds of data types, even same way we have, in your English language or any other language, that we have. You have numerals, you have decimal points, you have letters and all of that. Same thing, you have them in program. And the way you deal with them depends on what kind of data type it is, right? So we talked about sequence types, and I said strings, list, and tuple. We haven't done anything about tuple. We're going to get to that at some point. Um, the difference between list and tuples, and then we have different kinds of numerical types, your integer, your floats, or your complex numbers. And then you have different kinds of mapping types. One of those is your dictionary, which is the mapping type dict. So in those parentheses, all you have is the short way of referring to them. And then you have what we call bool or booleans. And then you have sets and then frozen sets. These are all different kinds of, some of them are more common than the other. And one of those that is one of the most, the or four of, or maybe five of the most common will be strings, which is this, lists, integers, floats, and bool. And in fact, let me say one, two, three, four. That's four, five, and six. Those are really, really very common. The ones that aren't particularly very common are the complex number and the frozen sets, and probably the set. Set also happens, but you can get away with that. So I mentioned what a string is, and I said you needed to, when you have a set of letters, right? First of all, we mentioned one of those things that isn't here is char, which is character, right? It's just a letter. One letter is what you call char. And then you would have strings, which is a combination of more than two numbers, right? So it could be a whole sentence, it could be a whole paragraph. That's essentially, uh, they are all referred to as strings. And the way you know a string is because you have these letters that have been put into quotation marks, opening and closing quotation marks, right? And in this particular case, we said the reason why greeting, for example, is not in quotation marks is because it's a variable. If it was a string, it would have been in quotation marks, right? And I think we had talked about print, which was our first when I told you about how your first code, which is Hello World, and that's when we use the print method to demonstrate that. So I'm going to be moving fast since we already have done all of this, and we have those in the videos. I've posted it in two of the classroom and also in the Discord channel. So you're going to be able to see that, and I will do the same with these videos today. So I talked about integers. Integers are just any whole number which can go from anywhere from minus infinity to plus infinity. So 10, 20, 30, 1,000, 4,000, 5,000, 8,000, 9,000, 20,000, all of them, right? Minus 20,000, minus 1 million, minus 1 trillion, provided it's a whole number, is considered an integer. And the way it's represented in a code is int, right? You're going to see int all of the time. And floats are about the same thing as integers. The only difference is that they are decimal numbers. So if you have 19.99, for example, 3.75, that's a float, right? And then you have Boolean. Boolean is essentially yes, no, true, false, zero, one, all of that. For those of you that probably did electrical engineering, you remember uh, uh, um, your positive and your negative type things that you have both in electrical and what do you call it now, electronics, right? or an AND gate, for example. All of those fall are like Booleans. So they are usually used to test whether something is true or false. It's positive or negative. It's always used whenever you have only two options, right? You can use Booleans to test that. Now, then we talked about how you can actually try to figure out what type, data type, right, something is. And we said you can use the type um, open and close parentheses. This is what I refer to as a method. Again, when we start dealing with much later in the class, you're going to understand what a method is, right? A method is almost like a function, which is a piece of code, right, that does something, right? So, but you have some of these codes that are internal to they are internal to Python that you can actually call, and type happens to be one of them. And then notice what's going on here: print, open and close parentheses, and then inside it you also have type, open and close parentheses, and you're trying to figure out what type of data type name is, and then that is telling you is a string, and then it's an integer for which of them is this? Yeah, age. Okay. Now, okay, let me just copy this so that it doesn't confuse someone when they try to do this. But remember, one of the things I said, right, is name, age, height, and his student. All of them are somewhere up there, right? The system is just calling them up. But for the sake of people still trying to understand this, you know what I'm going to do? I'm going to go up here. Let me see. Name. Where is name? Name, name. I'm trying to find name. It's further up. So this is it, right? So let me copy it again here, mm, so that you can actually see it, so that it doesn't become confusing and you're like, where did that come from? So here, so I'm going to create a cell and I'm going to drop this, right? So now when you run this, now you actually understand why name, for example, is a string, age is an integer, which is this 16, height, right, is a float, 160.5, right? And a student is a Boolean. So that's, and then you can convert something from one form to the other too. You can do that with something like this, right? So this, for example, 42 is a string, right? Because you put quotation marks around it. What if I just have 42, or I want to convert 42 to an integer, right? I can do that. And this is how you do it. Just int, put whatever that variable is, and then it will convert it to an integer and all of that. And that's how we have all of this. And then one of the last few things we did, okay, probably before the last one, was we were talking about input, right? This is also a method, right? Which is essentially what it does is it can actually ask you, it's a mechanism that you can use to ask the users of the application you have created for information, and then you can input that information into the code you have written, and then it's able to do something. That's what int does. So, and this is an example. So I try to run this again. You know, if you run this, it will ask you, what is your name, which is what you have here, right? Int, what is your name? So let's assume I want to just alter it so that you can see what is your father's name, right? What is your father's name? You know, it's going to change from what is your name to what is your father's name now. And very simple, because I run this cell not executed due to pending input. Okay, because it's already asked me for something. Let me say Kalu. Kalu. Now it's not going to execute until I've finished everything. Where do you live, Kano? How old are you? 1,000 years old. And then it executes the command. But right now, if I go run it again, it will now ask me, what is your father's name, right? So, um, John, Where do you live? I can alter that to say where does he live? Just something. Kano, right? And then how old is he? 120 years, and then nice, blah, blah, blah. So I go back to this. What is your name? So you can put in any number of things you want there and collect any amount of information that you want from the user by just using the input method. So next thing is string formatting. We did a bit of this the other time. Favorite hobby is equals to, and I can use my input. Same thing I use mechanism to collect data, but this is where the string formatting actually starts, right? Where I said there's something called an F string. What is an F string, right? So let me just take us on this ChatGPT journey. What is an F string in Python programming? Hmm? So an F string, short for formatted string, literal is a way of embedding expressions inside a string literal. So it gives us an example here, right? Name is equals to Alice. Her age is 30. Now I can simply come here and say F, and then I open parentheses, right? My name is, and then you put curly braces. That curly brace essentially, is a variable, but then what it does because of the coils you put around it is that it pulls whatever information you have here. Same thing with age, right? Age, it pulls the information that you have in age, right? So that when you run this, it gives you something. My name is Alice and I am 30 years old, right? So somebody asked the last time, why do we need to use the F string, right? And I'm just going to go ahead and discuss that because we already did that the last time. Is essentially once I define my variables, right, I can write an entire book, and everywhere I place the curly braces with my variables, I'm able to change those values, right? Just with one change, right? Where I've defined my variables, if that makes sense. But if you do have a question or you don't understand what I just said right now, please just type in. Yeah, Adrian, I was talking about logic circuits. You're correct. Yeah. So, if you do have a question with anything we've done right now, because my goal is to make sure you understand these things. I'm not going to be able to teach you everything you need to know in Python, but some of the most basic, right? I want to get you to a level where you can actually go out and get the information you need and get the things done. All right. So the next thing is what we did the last time. If you still remember this is where the question was asked, why do you need F strings, right? And we wrote this whole thing all over the place. You have, for example, look at these strings: color, 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 toy, country, color, toy. So here, what I have is my color. If I run this, all of a sudden I have my color all over the black, 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 black. I can be like, okay, I'm tired of black, right? I just want to go to white, right? Boom. Now I don't have to go in here and change the white all over the color all over the place. Just by changing this, I'm able to change everything in that sentence, right? So you can see the color changes to white, 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 and that's why you do F strings, right? Concatenation. We didn't get to this point, I think, and I'm going to continue from there, right? Concatenation. So in Python programming, concatenation is the process of joining strings using the plus operator, which requires manually converting non-string data types using functions like str, right? So I'm going to explain what that means, right? In everyday people speak, right? So I have name. My name is equals to Alex, and Alex's age is equals to 18. So he says my name is plus name plus whatever, and I am plus then string plus y years. right? So the point is, why would I be doing this, right? Now, remember that 18 here is an integer, right? And I'm just trying to write a sentence. I'm not trying to do a calculation or anything. So it would be prudent, right, in programming sense for me to change, make sure everything that is in here is a string. But I know that age is not a string. So how do I convert age to a string? Remember what we did just a couple of minutes ago? I just put str in bracket and I now put age, right? Age already all by itself. So let me um, age by itself, as you can see here, because it's a whole number, it's an integer. But then I want to change it to a string, right? And that's what I do here. That's why I said in Python programming, concatenation is the process of joining strings. So here, this is a string. This name is a string. This is a string. This is not a string, but we convert it to a string, and this is also a string. So all you're just doing is just combining different strings. And eventually, when you start doing programming, you now understand why you actually, the point is, why not just write the whole sentence, right? And that's where it becomes important. All of those things would get a little clearer. So in programming, concatenation is the process of joining the strings using the plus operator, which requires manually converting non-string. So this is a manual conversion of a non-string data type using functions like str. So use str to convert any other data type into strings. So let's assume I say height, right? Somebody's height is equals to 11.67 meters. So let me try to put it here. Years old, and he is, and he is plus. Hypothetically, let me just say he is height, uh, tall, right? You see what's happening here, right? It's giving me height. So let me just go this way and see what happens. Ooh, right? Because we are doing concatenation, but I can now change this. I know this is float. So I can just say str, you know, um, there's there's something not right. Okay, this is what is not right here. Yeah, and this is not right too, because I'm demarcating them as strings. Oh, we need to allow some space. Okay, what's missing? Just 1 minute. I have my space here. I have my space here. What is missing? My name is. Oh, I see. No, this is where the space is supposed to be because it does not understand clear space. Sorry. And there's supposed to be space here. We don't care if there's a space here. Now I remember. So this is what you have, right? So if this is no longer a float, this is now a string just because you put this here and you convert it. So for this is not necessary, but I'm just going to talk about it. So before, right? It still works right now, right? Uh, we used format. Format was literally like your F string, right? And this is how it works. The format method offers a cleaner approach by inserting variables into placeholders within a string using the format method, right? Let me see. Let me put this here. Um, Oops, sorry about that. Where are we? There's something I want to demarcate this out so that it's obvious what it is. This, and then I will put this, right? So if I run it now, you see what it looks like. The format method offers a cleaner approach by inserting variables into placeholders within a string using the F format, enhancing readability and flexibility. So this is what we have. My name is this, and I am, it just opens and closes brackets, years old, right? Dot format. So literally you do all of this and you go to the back, right? And once after a sentence, you put dot format, and then you can open and close brackets. And inside the brackets, these are what you call parameters. You just pull all the parameters. Look at the parameters it is pulling. It's pulling main, name, age. It's not pulling height, right? But let's hypothetically, let me just say, let me put in height. So if you run this right now, this is what you see. My name is Alex and I'm 18 years old. But let me say, and by the way, I am, then I am this years tall. Sorry. If I run this without including what you might call it, let's just run it and see. Doesn't work, right? But then all we need to do is include height, right? If we run it now, then we have our height. So just notice all we have done, right, is we just opened parentheses, did our sentence, but we designated the spots where we want these parameters, right, to go 1, 2, 3, right? You can just come here. So in a sense, it's cleaner, right? Because you don't have to go putting each of these everywhere. But the problem is you need to know exactly what the position of what you're trying to do is. Yeah, but this is the F string, which we already did, is better recommended. So, and this is the most latest one in Python 3.6. Before 3.6, we didn't have it. We had it this way, but from Python 3.6, which is an updated version of Python, we now have 3.6. We now use the F string itself, right? Where you can place, what do you call it? The variables anywhere you want. You don't have to keep following, the order in which they are listed, and then you can get your results, which is what we have going on here. So for example, right, look at what's happening. My name is name, and I am this years old, right? But I can actually just come here saying my name is this, full stop, and I am let me just say I am then I come in here and say height, right? I come in here and say height, right? And I close. I hope I got that well. Tall. And by the way, I am blah, blah, blah tall. If I run this is what I get, right? My name is Alex. I am 11.6. I didn't include centimeter tall. And by the way, I'm 18 years old. If you did this with format, you would get it. Format will just pull in the order in which these numbers are and just fill it in there. So this gives you more flexibility. And if you don't understand, you have any questions, please ask right now, because I don't want to lose anyone. I want to make sure we're all going together. And then the next thing we talk about is the percent, which is how you format numbers. And I'll show you the specific thing. And it's also set up, it's a legacy method or way of doing things, right? Percent style formatting. It can look complicated. You can see if you've seen some piece of code and you're seeing things that look like gibberish, right? And this is me trying to explain what all that gibberish is about. Yeah, percentage style formatting is an older technique inherited from C, like the C programming languages, where placeholders like, now notice percent sign and S or percent sign and D are replaced by values using the percent operator. For example, age, then colon percent D, right? Percent age. While while still functional, it is generally less readable and less flexible than the F string. This is another way of also doing it. And notice what happened, right? My name is percent %S and I am percent %D years old. Then you come use that percent. So percent is literally you trying to same thing that happened here if you remember, right? Same thing. So that's the same thing. And then at the end, you now include the percent sign and whatever it is that you were trying to pull from. That's what it is. So where this represents this and this represents this, you know, for me, I would just straight up go use the F string. Now in Python, you can format numbers to control the number of decimal places using techniques like F. Then you put the value. So this is kind of different. And this is also your F string, remember? Yeah. Yes, ma'am. Go ahead. You can speak up.
Yeah, sorry. I don't want to be too lost.
No, yeah.
The percent D,
Yeah.
sorry, this percent formatting. Could you take
Mhm.
that again?
The percent formatting.
Especially where we have,
Mhm.
yes,
Yeah. Um, so go ahead. What were you saying? What's the question? You just want me to
please,
explain
could you
what's
take
going on
this
here?
percent formatting again? Yes, especially I see percent S and percent D. I think I lost it.
Yeah, you are correct. But so the thing is, frankly, it's just the same thing, just like what we did. Percent S just represents the first parameter, and percent D represents the last parameter. That's just all it is. And that's why I was saying it's literally like what you have here. Instead of percent D, it was just this and this. And I said eventually, probably more recommended to just use your F string. Does that make sense?
Yeah, it's fine. It's fine. It's
Okay.
fine.
Yeah. So, but let's go to formatting numbers with precision. This is the one that is, I think, even a little more valuable, right? So again, from what we just did, they keep trying to figure out ways to have you write code without it being cumbersome, percentage S, percent D, and all of that. Somehow it doesn't it's not intuitive. So in Python, you can format numbers to control the number of decimal points using a technique that's referred like F. But remember, this is your F string, right? And in your F string, what you do is you open a quotation mark and then you close your quotation mark and then you have your um, curly braces to pull whatever variable is inside. But now, if we are specifically trying to deal with um, you know, controlling precision, the precision of decimal places, round them up, round them down. We essentially use this syntax. The important thing is just to remember this syntax. And again, if you don't even remember it, you don't have to cram these things. Google is your friend. You're trying to do something like that. You just go type something like formatting numbers for precision or decimal, rounding up, rounding down decimal numbers in Python. It will just pull the information for you and then you copy and then you paste in what you're doing. So there's no point. I think the most important thing for most of what you're going to see in Python is for you to have seen it the first time or you've used it a couple of times, right? So that if you run into a situation where you need to know something, you know that it does exist, number one, and then you know what to go look for, where to go look for it. And then after you've used it for a couple of times, it now becomes second nature. You don't have to look for it. You don't have to do anything. So this is an example of where this is used. I think the use is actually more helpful. So this is pi. Pi is 3.14156, right? all of us agree it's a constant that everyone knows. But what if I want to round it up to two decimal places? All I need to do is just come in here, right? And notice what I've done. I start from my F string. So we are starting from F. Let me just remove all of this so that we remember where we're starting from. So all we're starting from is your F string, right? And then you come in there and then you type a string, your string. This is your regular string that you know, and then you put in a colon. That's all you have done, right? To to now manipulate that your decimal, all you now do is after your colon, you open another string and then you just type pi. So if this was something else, right? Say, let's say this was X, then this is supposed to be X. That's all it is. This is supposed to be X, you know. But if I run this, it's going to give me error, except I change all of these too. So I'm just going to stick with my pi, right? But it's just the same thing. It's just this number that you're pulling, right? And then you now put a colon dot 2F. That 2F just tells it is two decimal places. Dot 3F tells it's three decimal places. Dot 4F tells it's four decimal places. So when we run this, essentially gives us this. So, and here I try to explain what's happening. Here's what's happening. The variable P, which is pi, is assigned the float value of this. So we get this float value, right? Like it's float because it's decimal places. That's the type. Then inside the F string, right? Inside the F string, this is your F string. Inside it, right, we now have these elements here, right? Pi, blah, blah, blah. Inside the F string, this, which is this, formats that number, and that's the formatting that it does. So what it does here is dot F means fixed point notation. That's what dot F means, right? And that is two digits after the decimal. It rounds up to this, rounds up this to this for two decimal. So that's essentially what it is. What else do we have? Okay, look at this. This is for percentile score, and you say dot one is a dot 1%, right? And that's where, even though you're converting this to percentage, which is what we have going on here. And this is just all you use. And all of these things, right? They are online. You just have to know that they exist and just go Google them or chat them up nowadays. So same thing here, right? I have mass is equals to, and then I want it to be two decimal places, but I want it to be in the engineering notation. Remember, engineering notation is almost like e to the power something, right? And that's why we have this 2e. But you don't have to bother yourself about all of this. It's just to show you that they exist, because most of the time you're not going to be using them, right? So because of that, I'm just gonna pass along, do whatever you got to do here for all of this. If you have any questions, this is me trying to create a table with all of this, and then there's a practice exercise that you can try out for yourself. Yeah, so I'm going to have to run to something else so that's control. So um so I'm going to do a bit of this and then we'll take a short break because we are almost bumping into the hour, and then we'll take a short break. Okay, yeah, go ahead. Oluchi.
Yes, sir.
Yes, ma'am.
So, are we going to have access to these exercises or workbooks?
Sorry?
Because you just mentioned now, are we going to have like access so that we can practice with them? Are you
Yeah,
going to share them?
yeah, I already shared this, but I will share it again before we leave, or
Oh,
after the classes. I already shared it the last time that they came, so
okay. I
we all
don't
have
have
it.
it.
So I'm going to share it again. And
Okay.
more importantly, the meat of the matter is in the textbook I shared with them the last time, right? Because you
Yeah.
can literally go in there and walk through that textbook. It has all the information you need.
Okay.
Yeah.
Thank you.
Yeah. Thank you. So for week 2, um, after you have done like the types, right? Control, how you control the flow of data and your logic, right, is really, really very important in programming. And I will believe most of us have gone through it before, in our computer programming classes. Maybe you really didn't care much about it or whatever, but well, you have to face it again now. But these control mechanisms are really, really very important in programming. So it'll be important that we touch on them a little bit. But that book does an excellent job of walking you through the steps and the processes of each of these flow mechanisms, right? So the first thing I want to mention, and when we come back to class later, I'll probably discuss it more, but I'm just going to do a quick overview of some of the most common control mechanisms that we have, right? So one of them is, and the other thing I haven't really talked about, maybe when we come back, is lists. I mentioned that I was going to do something about lists. So I'm going to do that once we come back, because lists, even though we are moving into control mechanisms now, we still haven't finished lists. So I'm going to go back and walk us through lists and how to manipulate lists and how to work within lists, pick data out of lists, put data back into lists and all of that. And then after that, we should be able to help you understand how to slice up disk list and collect any elements you want within a list. So let me just do an overview of this, but this would not be the main time we talk about this. I'm just going to introduce this, but hopefully maybe the next class would now expound on this and break it down at a level that like anybody can understand. But let me just start with introducing it right now because it's very important. Now, there are all kinds of, let me start. This week we would explore how to control the flow of your program using if, else if, and else, right? And these are different kinds of loop. It's usually called the if loop. There is the if loop, there is the if else loop, there is the else loop, there is the while loop. There are all kinds of loops, right? Maybe about at least the most common loops, I think there are like 5 of them. And most programs that you have, right, would have them playing some kind of role, in those programs. So understanding comparison and logic operators, that's what this topic would help you understand. You would use if, else if, and else to create decision-making programs. So all of these flow mechanisms, right, or loops, one of the key things they help you to do is making decisions. So if you're walking and you come to a junction, right, that has three trajectories moving in different directions. It helps you make the decision which of the roads should I go through based on some condition, right? It's something like that. So comparison operators. Now, these are important because within, usually they are used to test conditions. And again, if some of the things I'm saying don't make sense to you, it's okay. What is going to be important is when we start using specific example to to just okay. It will be when we start using specific examples to buttress the point, so things will come alive for you. So some of the comparison operators are, for example, equal, equal. So in programming, remember when I told you that equal to doesn't necessarily mean equal to that we have in mathematics. It just means that a variable is pointing to something. The real thing that says one thing is equal to the other is when you use a double equal sign. So what that means is, for example, if I say y is equals to 6, right? And y is equals to 6 do not mean the same thing. Yeah, this is essentially just saying that I want to store 6 inside a box, right? And that box, the address of that box or the name of that box is Y. It doesn't mean that this is equal to this. But when I say Y is double equal to this is actually your equivalent of X is equals to 6 or Y is equals to 6 in mathematics that you know on every day. Yeah. So if I'm trying to test something, right, and I say Y is equals to 6, right? So let me show you something. Let me say Y is equals to 3, right? Let me run it. Did you notice what happened? Now I say Y is equals to 3. So, and then I'm asking, is Y equivalent to 6? And it says false because it's not. Questions? So, and then there are all kinds of things. So this the what do you call it? Exclamation mark and equal to essentially means that something is not equals to. So these are all mechanisms that you can use to test something or test a proposition. And I'm going to show you, but just gobble this in, understand it, and then let's look at these examples because it will help us understand what I'm saying better. So look at, we run this test right now. Essentially what this is doing is just testing, is 5 greater than 3? And it says, yes, it is true. So is 2 equal to 2? Yes, it's true. But if I ask it, is 2 equal to 3? Of course, it's going to say false because 2 is not equals to 3. So if I say is 4 is not equal to 4, we know that 4 is equals to 4, but if I'm asking it, is 4 not equals to 4, it will say it's false because 4 is equals to 4. So essentially, it's excuse me, it's used to test conditions, and those tests are important because when you want to run those what do you call them now? Once you want to do your logic, right, or run your program, run some logic on your program, right, you test them with conditions, and that's where these ones become important because you want to test something, and then if you test it and it's false, it does one thing, but if you test it and it's true, it does another thing, right? So that's where the comparison operators become important. So the second kind of operators you're going to encounter is your and, or, and not, right? So let's look at an example here, right? Age is equals to 16, right? So people that are age 16, do they have permission? Has permission? We said true, right? So I come here, I'm like, age is greater than or equal to 13. Now, question to you, and I want some actual response. Age is greater than or equal to 13. Is it true or false? Age is greater than or equal to 13. True or false? You can
That'd be
type it.
true.
It's true, right? Does
Mm-hmm.
everybody know why it's true? If you
Mm-hmm.
don't understand, yeah, because we know that age is 16 and
Yeah.
16 is greater than or equal to 13. So now you have and notice that the and, right, is blue. True is blue. Or is blue. So these are those reserved names, right, that I told you about the last time in Python, right? They are words that mean specific thing within Python. And we said right? And is true if both conditions are true, right? Just like in the English language, if I say John and Peter must go, right? I'm not saying it's John or Peter. It has to be both of them. The condition says both of them. If I say John or Peter, then I'm saying I want one person, I don't want both of them, right? That's the same thing that is going on here. So it's very intuitive. So if I say John is a boy, right? That's straight up. But if I say John is not a boy, all it does is that it inverts that result. Same thing that we have in English, right? That's what the not is. So for this particular place, I say print. Print age is greater than or equal to 13 and has permission. Has permission is true, right? So we know that age greater than or equal to 13 is true and true. Therefore, it's true. That's why it's true. Then the next one, we now ask ourselves, age is greater than or equal to 18, right? We know this is false because age is 16. 16 is not greater than or equal to 18. So that's false. Or has permission. Has permission is equals to true. So what we have is false or true, which is true because remember, for all, when we're dealing with all, it's either of them can be true. It doesn't have to be both of them. And then we have print, not his permission, not has permission, right? Has permission is just a variable and it says it's true. The moment I put not, so this alone is true, but once I put not, I'm inversing that result, right? Which is why I'm getting false here. So when I run this, I get true, true, false, right? So let me just put an additional one where I do not invert the result, right? I just say print has permission, not inverted. So not inverted, right? So notice the way I'm putting in a comment so that anybody that is reading this code will know what I'm trying to do there. And the way they put all of this and the way you do it is you use your hash tag. So if I run this right now, all of a sudden this is true because print has permission, which is has permission here is said to be true, right? So now we want to look at a couple of examples. Well, let's take a break, 10 minutes break, and then let's come back and then I'll walk us through the if, else if statements and all of that. Is that okay?
Yeah, sure.
All right, sirs.
Yes, sir. Thank you.
Yeah, I will. So we will be back. I'll put something on, we'll be back by what you call it now, 6 minutes past the next hour. Six
So please,
minutes.
can you leave me with the last line, the last lines of code that
Oh,
has to do with has permission.
okay.
Yeah, please. That's
Okay.
fine.
Okay.
Thank
For
you.
for
Thank you.
other people, right? Sorry, for other people, just come back by 3:10. 3:10 is fine. Okay? 3:10. Oh, sorry. 8:10. Your time. My time is 3:10. Yep, let me go back. So were you talking about this? Hello, ma'am. Who was speaking?
It's me. That's fine. Where we are is okay.
Okay, so what was the question you were asking?
Yeah. No, I just wanted to get this into my notes.
Oh, okay. Sorry about that. I got it. Got it.
So, sir, if you share that,
Okay. Yeah, so this is an example of what we were talking about, right? The if statements in Python, right? So, and this is what the basic syntax of your if statement is, right? Basic if your basic if statement, because there are all kinds of if statements, but the simple if statement just says if a certain condition is met, which is what we have here. If a certain condition is met, then do something. So remember when we were talking about uh, those, what do you call them now? When we were testing those propositions, right? Greater than or equal to conditional operators, that's where the condition operators become very useful. So let's look at one example. The code runs only if the conditions evaluates to true. So we're going to do something only on the condition that this this condition is true. So this is an example. Let's say x is equals to 10. And then I start with my if statement, right? And notice the if, right, is blue. Sorry, it's green. And I was mentioning that certain words, right, are reserved words. And if is one of those reserved words, right? And when you have a reserved word, it means that there is some kind of code running in the background that is called each time that word is in operation in like on the surface. Like remember when I was doing the analogy with a car that everything that powers a car, right, is under the car or in the boot, right? But you're literally sitting in there. You don't care how those things work, but you have your accelerator and your brake and you control all of them, which is in programming we call abstraction. In other words, you're hiding away all the difficult things and you're just using a little thing. In this particular case, that little thing is if, right? And there's some code running behind that determines the behavior of if. And that is based on this syntax. If a certain condition do something. So we define the variable and our variable is x. X is equals to 10. We all agreed on that. Now, if x is greater than 5, then do something. In this case, the question is x greater than 5? Without the code being run, we know that x is greater than 5 because x is 10 and 10 is greater than 5. Therefore, x um greater is if is x greater than 5, which is true because it evaluates to true, then print executes. Now, it doesn't have to be print. It can be any number of other things, right? When you're writing a code. So you can go from print and put a condition. Every time it evaluates to true, drop a $5, a $10 bill into a bucket. That's a condition, right? That is met. And then they do something that it is doing. So you can tell it to do any kind of thing if those conditions are met, and that condition has to be true for it to execute. So in this case, the condition is met, and then what it was asked to do is to print something, and it did print it. So let me change this, right? Let's say I change this to 1, right? Guess what? It doesn't print anything. But if I'm writing a code, I don't want that to happen, right? If it doesn't print, then I want it to do something else, right? So I go back and I put my 10, I run it because it meets that condition, it evaluates to true. But then for me to ask it to do something else under a different condition, that's where you now bring in your if else. In other words, if I do this and it doesn't work, then do something else, right? So using this as an example, now I didn't write x is equals to 10, but it is implied that x is equals to 10. Like I told you, codes run from the top down. And until I change the value of x somewhere, even if this is 1,000 feet deep up there, it's still going to, everywhere x is called, it's still going to refer to that x, right? And it's a variable because I can change it at any time, right? And that won't be a problem. So I'll say if x is less than 5, then print x is less than 5. Else, in other words, if this is not true, if this condition is not true, then print x is not less than 5, right? So hypothetically, let me just assume that I bring this so that it's within our view, right? So that you can see it. And I'll say x is equals to 10. So we know x is equals to 10. If x is less than 5, and we know that 10 is not less than 5, so that's false, then that's why we don't print this. So when a code starts running, it starts running from the top to the bottom. But then if it encounters, if the conditions are met, then it completely stops running. But if the conditions are not met, it keeps running till it gets to the end, right? So in this case, right, x is not less than 5, so that's false. But let's look at a situation where x is equals to 1, which is 1 is less than 5, right? Guess what will happen, right? And see what it prints. X is less than 5, which is this. What happened to else and all of that? It does not do anything. It just stops, right? Because the condition has been met. So I go back to this and I run it, right? Instead of saying less than now, it will go to is not less than, right? Why? Because the condition wasn't met here and it moved to the next step. Then look at another condition that shows up here. If, if, else, so it's like you're doing, if this happens, then do this, else do this, you know, else. So you don't just say else, you said if this happens, do this, else do this, else if do this, else if you can, so you can continue with your else if till infinity and finally close with else. Right? So this is an example. So there are other mechanisms that you can use instead of continuing to say, for example, have 100 of these, testing all of this, and we'll get to another mechanism later. But these are some of the basic mechanisms that you can use in your programming journey. So again, we have our variable, and then we have our integer, as you would remember, and I want to keep chipping in this thing so that it becomes second nature. Now, if the score is greater than or equal to 90, then print grade A. If the score is greater than or equal to 90, then print grade A. Now, the question is the score greater than or equal to 90? No, it's false because 85 cannot be greater than or equal to 90. Then that means grade A is not going to print. And then it goes else if score, which is 80, is 85 is greater than or equal to 80, that's true. So it can create grade B. That's why I created grade B. And then what happens to the next of the things? It doesn't do anything. Why? Because the condition has been met here and the program stops by itself. So that's how we do this. So if I go add more and more things, right, it's going to keep doing the same thing. Right? And then there is also what we call the nested if statement, right? Age is equals to 25. If age is greater than or equals to 18, if age is greater than or equals to 21, print this, else. But so one of the things you need to pay attention to is indentation. Indentation is really very important, right? Because these two, notice that this if is not on this if is not on the same line with this if. So technically what is happening is something like this. This if is inside this if, right? All of this code is under this. So everything that happens is going to be controlled by this if. So this is the grandfather of them all. And this is the son within there. And guess what? The if, this print, right, is under this if. If I move this if to somewhere here, I'm going to get a different result than if it is here. That's very important. So let's kind of run this, right? Let's kind of run this. So we're saying age is equals to 25 if age is greater than or equal to 18, right? And then if it evaluates to be true, it goes on to the next level to go test whether age. So let me just run it. Maybe it will make some sense. You know, you can drink alcohol in the US, right? So let's say 16. It doesn't do anything. Let me just take it back to say 22. It doesn't do anything because we didn't include a condition for it to do something. Because if we came here and said something like else, we say print, let's say we print, aha. Then this is a completely different case, right? Let's say 15. 15, you are too young. Too young. What did we just do? Else unterminated string literal detected at line 8. Unterminated. Okay, this is the unterminated string literal. So let me run. What else?
For your else spring, I think okay, that's fine.
Yeah. So you see the way I'm reading this tag, right? Because I had a coily brace here, and then it says closing parenthesis. The coily brace, right, does not match opening parenthesis, and that's why it's stopped me. So you see how this works, right? Initially, we didn't have this else if, so there was nothing to revert to when the person was younger than 18 and also younger than 21. So my point is you can play around with these things and build whatever, depending on what the problem is that you're trying to solve. You can use these conditional statements to just do it, provided you understand how, the conditional statements work, and then the conditions themselves that you have placed on them, you know. Again, this will not be the last time we talk about this. I will still take us back again. So don't fret. It's such an important topic that we're still going to do it. So remember our logical operators, right? And this is an example. So let's say temperature is equals to 25, maybe degrees Fahrenheit, degree Celsius, whatever, but we don't care about the units now. And the humidity is equals to 60. So I can actually write something like this. I say, because what we are trying to emphasize is the and keyword, right? The and keyword is saying, if we say and, then the first condition has to be true, and the second condition has to be true for the print to occur. So if the temperature is greater than 20 and the humidity is less than 70, right? So if you go up here, the first thing we'll ask ourselves is the temperature greater than 20? Yes, so this is true. And now we're testing for the next condition. Is humidity less than 70? Yes. So true, true. Because this is true and this is true, therefore we're going to print whatever is here, which is nice weather, and that's why we have nice weather printed. So it doesn't matter how you arrange it. The important thing is that you follow the syntax, test for the conditions, and then go ahead and ask it to do whatever it needs to do. If it's true, it will do it. If it's false, it would not do it. And then if you want to tell it what to do if it's false, then you go to your else and all of that. Yes, ma'am. Go ahead.
So let's imagine here
Yeah.
that temperature greater than this. Let's imagine temperature.
Mm-hmm.
We assign 15 to temperature. Let's run the code and let's see how it's going to be.
Yep.
You mind?
Yeah. You see, it didn't do anything. You see, but I can decide, I'll come here and say, but notice that I can't put else here, right? If I put else there, I will get the wrong thing because the else will supposed to be on the same line with if, because now what we have is an if statement. To make it an else statement, I have to put the else where the else aligns with the if. So I'll say else, right? And I'll say something like this, then I'll tell it what to do. Print. And notice how it smartly puts my print on the line and not at the end. Because if you put it at the end, it will now be responding to this and not to this. So this print is under else, right? That's what happens when else becomes true, right? Then I will say yuck weather. Yuck weather, right? And then I close, right? So let's run. Make sense? So just that. All right. Man, why are the storms being crazy around here? Okay. So you can do all kinds of things. That's why you go see some lines of code and you're wondering, what are these people doing here? And that's like your one-liner, because all you're just doing is you're squishing everything together. Now, for your one-liners, right, what you call a ternary operator, use it to assign values conditionally. Let's say value, if this value is true, if condition else, value if false. So this will be true, and then you put in a condition and else, and then uh, if it's not true, this happens. If it is true, this happens, right? So this is what you have here, where you say x is equals to 7. We all agree with that, right? The result is equals to, then we say even if x, so if x, you remember what this is, right? This is I think it's called a modulus operator. Yeah.
Yeah.
Yeah. So what we are trying to test here is whether, like, if something is even, right, then the modulus operator is going to be equals to 0. Else that thing is odd. What's a modulus operator? Let's go to, let me see.
That's the remainder.
Yeah, but I need to be able to explain
The
it for
remainder
people.
when
Yeah, go ahead.
that's the remainder. Okay, you're going somewhere to check. That's fine. You can check there.
Yeah, so I'm trying to look for a way to explain it to people that might not know what a modulus operator is. You see what I mean? So look at this. So look at something like this, right? Let's go use an example. Let's go use an example. So if I say, what example would I use? So let's go look at that code again. Let me just collect the code and show you something.
Try to explain that if it may help us.
You say what?
Can I try to explain the modulus operator?
Absolutely.
Let me try to explain it.
Mm-hmm.
Let me try to explain it.
Yeah, go ahead.
Now, if you look at modulus 2,
right?
Now, when we were kids, they will say 1 divided by 2 is cannot.
Yeah.
They will say 1 divided by 2 is cannot. Okay?
Mm-hmm.
Now, for modulus divided by 2 now, it will be asking, what is the remainder?
Correct.
When you have successfully divided something. So like that one we used to answer, 1 divided by 2 cannot. The modulus is actually 1. It wasn't possible to divide. So, but it still left something that has not been touched. That is the remainder.
Yeah, that's
so
what a modulus is.
Yes. Okay, so now when you say 4 divided by 2, okay? 4 divided by 2, there is no remainder. Okay? Are you with me? So the modulus there is 0. Is 0. So when you're talking about even number, the modulus must be 0. I don't know if it makes sense.
Do you all understand?
So remember that when you have divided something, when you have successfully divided something, the remainder after the division is modulus.
Yeah, so let me try to put something here, right? So let's say if I say 100, my people, 100, let's say 10 divided by, and this is a division sign. If I say 10 divided by 2, right? What is 10 divided by 2?
5.
5.
Yeah, 5. So it is 5 remainder 0. Does that make sense?
0. Yes.
Yeah. So modulus is trying to say when I divide something with another thing, right? Instead of giving me what that value is, it's looking for the remainder. What is the remainder? Does that make sense? So,
yes.
So for example, 7 modulus 2. If I say 7 divided by 2, what is my answer?
3 remainder 1.
Exactly.
Remainder
So
1.
if I say 7 modulus 2, the answer will be 1. That 1 that is the remainder is what the answer will be. And I'll explain why. So modulus is an operator that is used to test whether something is even or odd. Because when something is even and you divide it by, say, 2, right? You divide it by 2, it's always going to give you 0. 100 divided by 2, yeah, it's going to give you 0 as the remainder, right? That's what's happening. But if it is not even, right, it's going to give you some value that is not 0. That's what a modulus operator does. Yeah. So that's what they are using to test this proposition. So we're trying to figure out, if I have a value equals to 7, right, and I'm trying to test whether it's even or odd, instead of writing some complicated code of 7 divided by 2, blah, 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 all I just use to test it, I'll be like 7, which is x, modulus 2. If 7 modulus 2, right, is 0, then 0 will be equals to 0. But somebody just said right now that 7 divided by 2 is 3 remainder 1. So x, which is 7 modulus 2, is 1. And 1 is not equal to 0. So this is going to be false. Does that make sense? So in this code, we are saying, well, we are going to test both of them, this or this, right? We're going to, the result will be even if this is equals to 0, right? And we know it is not equals to 0. Therefore, it is odd. And that's why we get this result odd. Now, if anyone doesn't understand, just type in something or just say something and I will take it back again and look for another way to explain it. And it's okay, especially if you're hearing it for the first time, right? It might be kind of odd. So let me put another word. Every one of us knows that 8, for example, is an even number. So if I run this right now, it's supposed to, all things being equal, give me even. Why? Because if x, which is 8, modulus 2, 8 modulus 2, let's start with 8 divided by 2 will give us 4, remainder 0. Therefore, x modulus 2 is 0 because what modulus is looking for is the remainder. Here, the remainder is 0. 0 is equal to 0, which makes it true. So if it is true, then it is even. Else, it will be odd, but here it's even. That's why. So therefore, if we run this, boom, it will give us even. Make sense? Okay. So using if with collection. So we haven't quite, even though I introduced it a little bit when we started, we haven't quite really dug deep into lists. Hopefully that's what we are going to do when we come to class. I think tomorrow. Yeah. But we have a basic knowledge of lists. And a list is essentially you have a variable, which is fruit, equals to a bunch of elements, right, within a square braces, right? So like your square braces, you have these individual elements. And I said that you can have any kind of data type here. Here, what we have right now is string. You can have string, you can have integers, you can have booleans, you can have anything you want inside. But in this case, right, we are talking about fruits, and all the fruits we know about are strings, right? And that's why we have these strings. So this is a simple if statement. I can actually use an if statement to run through a list to look for whatever I am looking for. All I need to do is if, and notice the reserved words, right? One of the reserved words, as you can see, it's blue, is in. And in the background, there is a code running, and that code is essentially saying that just check if this thing banana is inside of this box called fruits. And that box, right, is a list of fruits. That's essentially what it is. So if banana is in fruits, right, print banana is in the list. What if banana is not, right? So that's where you now come with your else. Else colon print it's not in there, right? That's what you do. So for this right now, let's run it. If we run this, yeah, banana is going to be in the list, right? Boom, banana is in the list. But which other fruit can we put in here to test that we know that is not in the list, right? We can say something like cherry. Cherry. If cherry is in the list called fruits, then print, we can still change it here and say cherry. Yeah. Sorry.
Cherry is there.
Yeah.
Cherry is there.
Oh, there's cherry there. Oh my God. Give me something that's not there. How did I?
Orange.
Orange. Aha. Orange. It is. Okay, I was just say since it is. Oh, you see? It doesn't. Did you notice what happened now? Is and in, right, turned green. Why? Because they are reserved words and I started using them. But how do I remove them from being reserved? I should convert this to strings. Does that make sense? What just happened?
Yes.
Okay. So let me just run this right now. Boom. See? Orange is not there. So I can just use these conditional statements to run. And it looks simple right now, but imagine if you had, what do you call it? A list that has 1,000,000 words in them or 1,000,000 different types of fruits. In some cases, you can actually have the same, like for example, I can still have another banana here, right? I can have another banana here, right? There are codes where you can run to literally find out how many banana are in that, which is what gives you an idea of why it's important to have things like this, because you can, it could be all words, right? And you're doing your data analysis and you want to figure out how many of these things are there, or you can want to find out what's the length and you use the, what do you call it, method, right? That's called len, L-E-N, and then you put in the name of your list there and it will print it out for you. So let me just try something like that. I think it will be something like this: len, open bracket, fruits. Right? I think it should be something like this. Let me see. So you see what I did? I said, look for this. If orange is in the fruits, print this. But if it's not, just give me the total number of fruits that are here, which is 1, 2, 3, 4. And then it printed the 4. How about if I just increase it, right? Let me just double the number and see whether it gives me the correct thing, right? Because if it's 1,000,000, it will still give me the same results, right? And then I run, and then it gives me 8. So essentially just the same thing going on there. So question? Professor Mary, do you have your hand up? Or was that from before? Okay. So,
Excuse me, sir.
yes, ma'am. Go ahead.
Please, I wanted to understand the difference between the using single quotes and double quotes and when to use them.
So,
Brackets,
yeah,
curly,
single quote and double quote will help you do the same thing. If I use single quote, it will still work.
Okay.
Yeah.
Then what about the square, curly, and the normal brackets?
The square and
curly braces, square brackets, the normal brackets.
So yeah. So some things are completely very specific in programming, as you are aware. So for example, list, right? List is very clear that whenever So let me, because it's something you're still going to keep learning as you keep going in your journey. So for example, list, right? When you're dealing with list usually has to be an open square brackets. You understand me? So tuple, tuple and list are almost the same thing. They do almost the same thing. The only thing is for list, right, you can change a lot of the things that are there. But if I'm looking for something, right, I want to put a bunch of things in a list, but I don't have any plans of changing them. Let's say I want to create a specific triangle, right, that has fixed lengths. And I don't want anyone to alter those lengths, or I don't want to mistakenly alter the length myself, right? Instead of storing the vertices of that triangle in a list, I will store them in a tuple because a tuple is immutable. A list is mutable. So the difference is that same thing, right, that you would have put in a list, you now put it in, in parentheses, So remember when we were, some of the things we just did today, right? When we are talking about the F string or something, we have a situation where you have, if you want to put an F string in something, you do something like this. You said, Abdul is a good, and maybe there's something I've listed there, right? Guy, he is, then I go something like this. He is old, and then I close, and then I also put my parentheses there. Yeah. Oops, sorry. So something like this, right? And maybe I'm trying to print it, and then I open and I close. So where did I use my curly braces? I'm just using these curly braces, maybe because I have written something like I've done something like age is equals to 34. So for me to pull this variable, the content of this variable, right? I come in here and I put age, right? And that's the situation where you're using curly braces. So you can see the difference, right? So just using, for example, most of the methods, right? You say print. Remember, they are in square parentheses. When I say something like length, which is the length of a list, right, is in curly braces. So it just depends on what the conditions you're talking about is. So it's very important you pay attention to all of those things because, syntax, in a lot of programming languages can be very strict. It's even very forgiving in Python, which is why a lot of people try to learn Python before they learn all the other languages, because other languages can be very strict. Where, for example, you actually have to define the type that you're going to use. In this place, we don't define type. We just know the type. But in some programming languages, you actually have to define the type before you even start using it. Okay, people. I think we are bumping up close to the hour. But I think, what are we going to do? I think we will just have to converge tomorrow. If anyone has a problem, excuse me, or a question you want to ask, I will be available to listen to the question right now for the next maybe 10 minutes or thereabout, and then we will be done. So when I come around the next time, I think I will try to focus on lists, to show you how lists work, and then we'll use some of those control elements to take things in, take things out, move things around, and then we would also do a bit of slicing, the elements in a list, right? If I want to pull them out, or I want to increase the number of elements in a list, how to do that programmatically, So that will probably be the next thing we do. All right. But people, I think it's about, yeah, go
Hello?
ahead, Professor. Yeah.
Okay, I know curly braces are also used when creating dictionaries. Would you like to tell us a little about dictionaries?
Oh yes, I'm gonna do a whole thing around dictionaries, right? But frankly, the easiest way to understand dictionaries, right, is to think of dictionaries themselves, you know? So it's very intuitive because essentially what dictionaries, so let me go and say dictionaries in, so this is an example if you can see it, right? So you see, like she just mentioned, this is a dictionary, and then you have coily braces, and that's how you identify what dictionaries are. But in very strict sense, what is a dictionary? And this is how to create a dictionary, but I'm still going to come back here, but let me just show you. So in a dictionary, right, if I want to find out the meaning of the word boy, I will say something like this, right? And then there will be a colon. And then the dictionary will say something like a male, a young male human. Yeah. Let's just say hypothetically it says something like that. A young male human, and it will say maybe between the ages of blah, blah, blah. Did you notice you have a word here and it's giving you the key, right? That's what a dictionary does. So by that same model, what they do in programming is there are a lot of times, right, when we actually do dictionaries, maybe we don't even know that's what we are doing. So if I'm filling out a form and I'll have something like name, I'll give a space equal to age equal to, now look at me saying Nama. No, that's going to be name. Address. So you're trying to create a profile, right? And all of that. So later, this is going to have, say, Shehu, right? And his age is 83. And his address is Turaki Road, let's say in Kaduna, right? So this is a dictionary. That's essentially what it is, right? So the same way we go about creating lists, right? Where I would have a bunch of numbers and I will store them in this container, right? And that's the same way you can actually store these words in a container. And then when you need them, you can call them. So when you go into a form and you're filling out a form and you have a form and you have your name and then you enter your name, you use like your input method, right? Enter your name, your age and you enter your age, your gender and you enter your gender, all of those things. At the end of the day, the system will pull all of that data, but it will store it as a dictionary. And someone can now manipulate that data and do whatever they need to do with that data to get the information they need. That's essentially what a dictionary is. But to doctors like points, the way you create dictionaries and you manage them is with coily braces. Does that answer my question, your question? All right. I think we have bumped up to the hour. So I shall see you all tomorrow. Hopefully I'm more prepared tomorrow. I have a couple of things I need to submit for a conference tomorrow, but I will try my best. All right.
Thank you, sir.
Yes,
Don't
ma'am.
Thank
forget to
you
send us
very much.
Yeah, thank you.
Yes,
the
yes, ma'am. So you were
Thank you so
asking
much, sir.
something? Yes, yes,
Oh,
sir.
thank you. Remember to share this
Thank
Oh,
you, sir.
all right. Yeah, I will share it. Thank you, everybody. Appreciate it.
Yeah, thank you.
Thank
Bye-bye.
you.
All right.
Bye.
All right.
Bye, sir.